Hi there, and welcome to a Papetti Math YouTube video tutorial where I'm going to be teaching you, yes you, Algebra 1. And in this video, we're going to be looking at exercise 2 in the lesson titled Domain of a Function. And we're going to be looking at the domain of a function that looks like the one in the graph. It tells us that the graph of f of x below shows a function graphed over a specific interval. First thing we want to do is we want to remember that we know how to evaluate a function based on a graph. So the first thing that we're going to do is we're going to evaluate f of -6. So again, it's normally looking like f of x, but the x is replaced with a -6. So we're looking for this on this graph where the x value is -6. So I'm going to go to -6 on this graph, and it's right here, and I'm going to follow it either down or up until I hit my function. In this case, I need to go up to hit my function. And I hit the function at this point right here. And that's the point -6, 4. So when my input is -6, that leaves me an output of +4. So if I were to evaluate or solve, I would get 4 as my solution. In part B, it says, is there an output for f of 3? Or for that matter, f of 4? So let's start with f of 3, and we'll go to 3 on the x-axis. And in this case, we're going to have to go down to hit our graph. And it's between two numbers here. So yes, there is an output for f of 3, but we don't know the exact decimal value. And that's because it's somewhere between -2 and -3. Looks a little bit closer to -3. So we could take an estimate that the range of possibilities it is, but we don't know the exact value, but there's definitely an output, and that output is -2 point something that we don't know. But there is an output, and that's what it's asking. Is there an output? Now for f of 4, we go to 4 on the x-axis and we follow that down. And remember, when we have an open circle, that's like a big hula hoop. And when we follow it down, we're going to go straight through that hula hoop. We're not going to hit the graph at all. And we're going to keep going forever and never hit that graph again. So there is no output for f of 4. So what we wrote was, yes, there is an input for f of 3, but we don't know the exact value. But there is no input, not an input, for f of 4. Because again, that's an open circle. And open circles are not inclusive. They're exclusive. So part C wants you to write the domain of this graph in interval notation. So again, there's that fancy word domain, which means write all of the x values in interval notation. So you want to look at just the x values on this graph. So what I'm going to do actually is I'm going to erase anything else on this graph right now. So we're dealing with just the graph that's given to us, nothing extra. And I'm going to take a dashed line, and I'm going to go straight up and down on the endpoints of my graph. And I want to see how far left this graph goes and how far right this graph goes. Because remember, x values go left to right. I'm not concerned at all about up and down. Those would be y values. And since the domain is x values, we're only concerned about left and right. So how far left does this graph go? Well, it crosses through the x value of -6. This graph does not go any further than -6. And then it's a closed circle at -6. So the graph does go through the point -6, so it includes that point, so we put a square bracket. Because again, we're writing this one in interval notation. Now we look at how far right this goes. What's the greatest x value? And it looks like it goes all the way up to 4. It approaches 4, but it never actually touches 4 because 4 has an open circle. So the way we represent that is this: we say it goes all the way up to 4, so close to 4, but never touches it. So we put a parenthesis with that 4. So now we want to rewrite this interval as a compound inequality. So what we're going to do is we're going to just take that -6, and we know that this square bracket transfers to a less than or equal to sign. Domain is x values, And then we know the parenthesis transfers to a less than sign. And finally, our greatest value is 4. So either way we write the domain as an interval or as a compound inequality, they both mean the same thing. Whichever one is easier for you, you're able to do when you're asked what the domain is. But if it specifically says to write it in interval notation or compound inequality, you have to do it that way. Okay? So in this video, we looked at a graph and we were able to find the domain of the function on the graph. If this video was helpful, please give it a thumbs up below, and you're ready for exercise number 3 in this lesson on domain of a function. Thanks for watching.